Hello students, in this video we will talk about aldol condensation. Aldol condensation is self-condensation of aldehydes with alpha hydrogen. Okay, self-condensation of aldehydes having at least one alpha hydrogen. So what is an alpha hydrogen? First of all, this is an aldehyde group. The carbon next to the carbonyl group The carbon next to the carbonyl group is alpha carbon and the hydrogen on that carbon is alpha hydrogen. Okay, so this is your alpha hydrogen. This is your alpha carbon. Carbon next to it will be beta carbon and so on. Okay, so here we are right now more concerned about the alpha hydrogen. This alpha hydrogen can be abstracted by any base. It can be taken away by any base. So conditions which are here required for aldol condensation are mildly basic conditions. So reagents like dilute NaOH, that is sometimes in your exam you may be just given dilute OH minus, or even aqueous K2CO3. Any alkali metal carbonate solution is also sufficient to initiate aldol condensation. Now, what is aldol condensation? In aldol condensation, if we have an aldehyde like CH3CHO, so in this aldehyde solution, if we add dilute alkali like dilute NaOH, we get a condensation product, that is CH3CHOH CH2CHO. We get a, this is what, beta hydroxy aldehyde. So look closely, this is an aldehyde, CHO group is there, and on the beta position we have an OH group. So this is what we call aldol. So the word aldol is nothing but it is combination of aldehyde and alcohol. So this is your aldol, and this reaction is shown by aldehydes or even ketones possessing alpha hydrogen. What is the mechanism of this reaction? Most importantly, we need to understand in organic the mechanism for this is, so mechanism step 1 is generation of enolate ion. So enolate ion is basically the ion which is formed here during the reaction that will work as a nucleophile as well later on. So what is being done here? So in an aldehyde with alpha hydrogen, what is happening? Carbonyl being an electronegative group, it pulls electrons from the neighboring carbons, and those in turn will pull electrons away towards their, from their hydrogen. So what will happen? This hydrogen will actually be little bit electron deficient, and like this. So any base can now come close to this hydrogen which is electron deficient and abstract H positive and form H2O, leaving behind a carbon ion like this, leaving behind a carbon ion this. So CH2 negative CHO, this is called enolate ion. This enolate ion is resonance stabilized. The formation of this enolate ion is also driven by the fact that it is resonance stabilized. How do we say it is resonance stabilized? So this negative here, CHO, These negative charge electrons, they go towards the next carbon, and the next carbon pushes the pi bond electrons towards back to the oxygen. So it forms CH2 double bond C O negative H. So here we can say it is having resonance. Now since it is showing resonance, we'll say this is resonance stabilized. This enolate ion will be working as a nucleophile. It can, so this CH2 negative CHO can act like a nucleophile and can attack the carbonyl carbon in the solution. So that is the step 2. That is the attack of enolate ion as nucleophile on a carbonyl carbon. So this was step 1. Step 2 is attack of enolate ion on carbonyl atom. So we have CH3CHO in the solution, and the enolate ion is also formed in the solution. So what will happen? This enolate ion attacks the carbonyl carbon. Why does it attack the carbonyl carbon? Because this carbonyl carbon is electron deficient. In the earlier lecture we discussed that this carbonyl carbon is electron deficient due to presence of oxygen which pulls electrons away from it. So because of that polar bond nature, carbon is electron deficient and it is prone to attack by nucleophiles which are electron rich. So electron rich nucleophiles will attack the electron deficient carbon of this aldehyde. So when it attacks, first it forms an alkoxide ion. So see, whenever any nucleophile attacks on your carbonyl, the double bond or pi bond electrons, they go back to oxygen because the maximum covalency, maximum bonds formed by carbon at any point is 4. So it will go back or negative. It will be CH2 CHO like this. This will get one proton from the solvent like water, that gets one H positive from water, which is a solvent around it, leaving behind OH minus. So that OH minus can be used in the same reaction again for by some another molecule. But what happened? This O negative obtains an H, making this. So this is what alpha beta. This is your beta hydroxy aldehyde. This beta hydroxyaldehyde is what we were talking about as aldol. It is also found, now the reaction is complete here beta, that these aldols are easily dehydrated to form alpha beta unsaturated aldehydes. Okay, how can we do that? So let us have that aldol CH3 CHOH CH2 CHO. If we just heat it in presence of acid or base, okay, very mild acid or base, anything will work. You just heat it. So this OH and one hydrogen from its neighbor, okay, one hydrogen from its neighbor here, they will leave the compound, leaving behind an alkene on that place, or a double bond like this. So this is now what? Alpha beta unsaturated aldehyde. So aldols can be dehydrated using a gentle acidic or basic medium to form alpha beta unsaturated aldehydes. Next we talk about crossed aldol condensation. In crossed aldol condensation, what we mean is, if you take notice, in the previous example it was just a solution of acetaldehyde CH3CHO. What if in our reaction mixture we have more than one type of aldehyde, if we have different aldehydes? So both the aldehydes can participate in the reaction depending upon how many alpha hydrogens they have or whether they have it or not. So first case is mixture of two aldehydes with only one compound with alpha hydrogen. So there are two aldehydes in the mixture, but only one of them has the alpha hydrogen. For example, a mixture of CH3CHO, that is acetaldehyde, and C6H5CHO, that is benzaldehyde. So here benzaldehyde, if you remember the structure better, benzaldehyde has a structure like this. Here it's alpha carbon, that is the carbon on the ring beta, that is the carbon on the ring does not have any alpha hydrogen. So this carbon here, the first carbon on the ring, has no hydrogen attached. So there is no alpha hydrogen with benzaldehyde. Actually, not only benzaldehyde, any aromatic aldehyde has no alpha hydrogen. So, but whereas we know that acetaldehyde definitely has alpha hydrogen. So since benzaldehyde has no alpha hydrogen, there will be no formation of nucleophile from benzaldehyde. It will not give one proton to a incoming base. Whereas if a base comes close to CH3CHO, we just discussed, it will form what? CH2 negative CHO. Okay, now we have one nucleophile and two aldehydes. So that nucleophile can attack both acetaldehyde as well as benzaldehyde. So if it attacks acetaldehyde, just as the above reaction beta, it will form. So whenever we write the product of aldol condensation, so there are 2 points. One, identify the aldehyde, identify the nucleophile. How do you write the product? First write the, in the product, first write the structure of your aldehyde, CH3CHO. So instead of the CH double bond O, write single bond O. Okay, like this. Make it O negative. This is the previous aldehyde. Connected to the nucleophile. What is the nucleophile carbon here? CH2CHO. That's it. This is your product. Okay. This will extract H positive from solvent. Okay. This will extract H positive from solvent to form CH3, CH, CH3, CHOH, CH2, CHO. Okay, this is how you write the product of aldol condensation. Similarly, try second one better. In second one we have C6H5CHO. Okay, benzaldehyde. Nucleophile is still the same, CH2 negative CHO. So when we write the product, write the aldehyde C6H5CH single bond O negative, then the nucleophile CH2CHO. Okay, this gets proton from the solvent to form C6H5CHOH CH2CHO. Okay, so this is your aldol condensation. If we have two different aldehydes, which out of which only one has alpha hydrogen, we get two different products. These can also dehydrate to form alpha beta unsaturated compounds. So CH3CH double bond CH CHO, and this can also dehydrate to form C6H5 CH double bond CH CHO. So these are the two different products formed by aldol condensation when we add a mild base in a mixture of CH3CHO and C6H5CHO. So how do we write the complete reaction beta? So this reaction can be written like CH3CHO plus C6H5CHO. If we add mild base, just like that, OH negative dilute is added. We form two compounds. Two compounds are, so abhi see, there is no sign of heating here. If no sign of heating is mentioned, then the answer is always aldol. If you say heating as well, then you take the last product, that is the alkenes. So product 1 is CH3CHOH CH2CHO. Product 2 is C6H5 CHOH CH2CHO. Okay, so in this case we have two different products. Second case will be the case in which both the aldehydes have an alpha hydrogen. Okay, second case we have both aldehydes have alpha hydrogen. For example, a mixture of CH3CHO acetaldehyde and propanol CH3CH2CHO. Now both of them have alpha hydrogen, so both of them can donate H plus from their alpha carbon and form a nucleophile. So when OH minus comes close to them, the nucleophiles formed is CH2 negative CHO and CH3 CH negative CHO. So see, these are the two nucleophiles. Both these nucleophiles can attack both the aldehydes. See, two nucleophiles and two aldehydes are there. So each nucleophile can attack other two nucleophiles. So what we get? We get two products by each nucleophile. Hence we have total four products here. So how we get four products? First, let us talk about CH3CHO. If it is attacked by CH2CHO, we get the aldol product would be CH3COH. So this is the aldehyde. Then CH2CHO. Okay, nucleophile added. If further heated, we get CH3CH double bond CH2CHO. This is product 1. Product 2 is when we have CH3CHO and the other nucleophile attacks it. Other nucleophile is CHCHO and there is a methyl group here. This will form CH3CHOH. Nucleophile is different. So nucleophile will be CH, CHO, CH3. If We heat this, we get CH3, CH, double bond, C, double bond is C, CHO, methyl. Okay, so these are the two products formed when the two nucleophiles attack acetaldehyde. Similarly, both the nucleophiles can also attack propanol. So product 3 will be when your aldehyde is this CH3, CH2, CHO plus it is attacked by this nucleophile. We get CH3, CH2, CHOH, CH2, CHO. Okay, then upon heating it will be dehydrated to form alpha beta unsaturated aldehyde. We get CH3, CH2, CH double bond, CH, CHO. Fourth product will be when it is attacked by the other nucleophile, that is CH negative, CHO, CH3. We get CH3, CH2 and nucleophile is CH, CHO, CH3. If this is dehydrated, we get CH3, CH2, CH double bond, C, CHO and Me. So in case of two different aldehydes both with alpha hydrogens in aldol condensation, that is by presence of mild basic medium, we get four different products. Okay, so this is your crossed aldol condensations.